Hi, my name is Andrew McLaren. I wanted to help you understand chromatography problems and also alleviate a little of the stress that you might be feeling around them. Because a lot of questions I've seen students being given by their teachers are a lot more difficult than what the AP exam really expects of you. So these two questions, one from the course description and one from the exam of 2017, are much more like what you're going to see, and they're not as bad as what some of the practice problems you may be being given by your teacher. So if you've got a dye here, it's going to get brought up when a liquid goes up that. You may have done this in class where there's some sort of paper and then you put that in some solution and then dyes get dragged up with that solution. No matter what liquid is going up, polar or non-polar, it's going to drag this dye up some degree, but it's going to depend a bit on what we're using. In this case, they're talking about, they haven't told us like polar, non-polar, solvent front, or anything like that. But what's important to note is that this thing is almost at the max. So the solvent's front, that's like as far as the water's gone up, this thing has nearly gone all the way up. So it is essentially going with the water. It's not bound to the paper very much, if at all. It, if anything, has a preference of being in the solution of the water or the liquid, and that solution is displacing it or making it detach. So the water or solution, the solvent, is interacting with the paper more than the dye. And you can think about this as it having a weaker attraction for the stationary phase than the mobile phase. So it would prefer to be in the mobile phase than in the stationary phase. They're not talking about polarities. Like you could have a very polar paper here, or you could or non-polar, and vice versa with the solvent. It's really big picture on this. So it's just saying there's more attraction with the part that's mobile. And that can get a little bit confusing with some of the details where they're talking about more polar or less polar things. So don't worry about those finer points. The AP exam is going fairly big picture on this. So we've got three different dyes. We've got A, B, and C, all getting carried up. And yes, I'm trying to use colors that are accessible for students who maybe have color blindness going on. So we've got these three dyes that have been carried up as this paper has gone. But the papers, because the solvent fronts are a bit different, that means that one of these has been in the solution a bit longer than the other. So if the front's higher up, the you've had more time with the solvent climbing up the paper. Um, which means you can't just look at just the height to see, oh, this is like this compound. You have to look at what fraction it's gone up. So if a dye has gone up half as much as the front, like what we see with dye A, that's basically a fraction where we're saying like this has gone up half as much as that. So in the same sort of deal, if this has gone up here, then the dye has gone up about half as much. So that's an RF factor. That's how much it's being retained versus moving with this front. And that's the best indicator for what dye we're looking at right here. So it looks to me like we have dye A in the unknown. And what's important to note is that they tell you in this problem that your solvent is nonpolar. And so that is quite useful. And they even tell you that the chromatography paper is a polar material. So we know that the chromatography paper is polar and the liquid is nonpolar. And this is pretty standard for the chromatographies. There is reverse TLC, which is going to switch them on you, but you're probably going to see something that's the normal way of doing this. which is having a nonpolar solution in a polar paper. In other words, one of these things is getting dragged um, by the chromatography paper or by the solvent front a fair amount, and the other ones that are more attached are not getting dragged as much. So if we think about this, it looks like dye B is not getting dragged that much. Um, and so that's pretty polar. So when I look at this, I'm seeing that that's polar, and that these are getting dragged quite a bit. They're dissolved in that solvent relatively nicely, and so it's moving up that. So it's not necessarily that it's non-polar; it's more that it's less polar, because these dyes are gonna be things that are somewhat polar, and it's more of like this is more and this is less in the big picture on these problems. All right, yeah. See, they're not too bad. It's just I think people get really confused with some of the finer points on this stuff with more or less polar solvent fronts and how that affects things. But that's not that big of a focus from what I've seen.